Okay, guys, so today we're going to be taking some C notes on global forces. This is probably going to be like the only C notes you're going to have to take for the weather unit, but they are going to be a little bit long, and I do need you to take very detailed notes, and you're probably going to want to draw a lot of pictures because it is kind of abstract what we're talking about. Okay, so when we talk about weather, we have to review over convection. So we first talked about convection when we were going over plate tectonics and how convection occurred inside the mantle. Now remember, convection is the movement of heat in a circular motion. And so back when it was in the mantle, because the core was hot, the magma would heat up and rise and become less dense, and then it would cool off and sink. So convection does have to play a role with density. Well, it's the exact same thing, but this time we're on the Earth's surface instead of deep inside the Earth. So convection within the atmosphere and the ocean is driven by the sun. The sun is the heat source that is going to drive convection. The sun heats up the water and the land and the water heat up the air. So this unequal heating is what's going to lead to it. So there's a constant flow of water and air around the earth, and this flow is to distribute heat. The reason why we have wind and the reason why we have ocean currents is because the earth is always trying to equalize the temperature. So let's look at this heat map picture of the earth. Notice that right here in the middle of the earth, it is very red. That is the hottest part, which is also where the equator is. Now, keeping in mind that the earth is a sphere. Think about when we were talking about direct and indirect light and seasons. The equator gets the most direct amount of sunlight, during the equinox. So, of course, that is the hottest place on earth because it receives the most direct light and heat. Well, now look up here near the North and South Pole. It's the coldest because it doesn't receive any direct heat at all. It mainly gets indirect. So the earth is always trying to move heat away from the equator, and the cold is always trying to move towards the equator to equal it out. And this is what causes global wind currents and global ocean currents. It is that unequal heating. So checkpoint. Here's a picture of some ocean currents. Why is it always trying to equalize the temperature? Again, the earth is heated unequally due to the tilt of the axis. So if I keep reiterating things again and again, you probably need to, put a big bubble cloud around this, outline it, arrows towards it. It's something that's very important. The whole reason we have wind, the whole reason we have ocean currents is due to that unequal heating because the earth is tilted. Okay? So let's talk about wind first, and then we'll go into ocean currents. The Earth is in a constant battle to equalize that temperature, but it's never going to succeed because our planet is always going to be hotter in some places than the other. So here's a great picture of what I was talking about with the way, because our Earth is tilted and the shape of it. Right around here, this area is going to get that direct heat. This arrow is going to hit it at that perpendicular 90-degree angle. And that's the most optimal angle to allow the heat to enter in through the ozone layer. There we go. Notice how as you move up and down, that angle grows. That is more of an indirect. So since the sun does heat the equator more directly than the poles, warm air and water will always flow away from the equator. So if you look at this picture, it's actually of ocean currents. Notice the red, whether you're talking about the northern hemisphere or the southern hemisphere, is moving away from the equator. So if we're in the northern hemisphere, then warm ocean currents are always moving north. If you're in the southern hemisphere, they're always moving south because they're both moving away. Cold air and water is always going to be flowing towards the equator to heat up. So in the northern hemisphere, they will be going south, and in the southern hemisphere, they will be going north. But notice that you can see these little circular motions, okay? That is convection, that moving, that distributing heat in that circular motion. So the air is always moving, and it's going to play into that density, just like when we were talking about inside the mantle. When things heat up, they rise and they become less dense. So just like yesterday or today's lab that we did in class, we realized how density can be affected by temperatures. So when things heat up, they expand, causing them to become less dense, and so they rise. And then as they're up here higher in the Earth's atmosphere, it is a lot colder, so it starts to condense and come back together, which causes it to sink. Now it's near the Earth's surface, so it heats back up again and rises. So notice there is a convection cell right there. So when this happens, it causes a convection current, which we call cells when we're in the air. So here's a really great picture to show you all of the wind patterns. Now, wind carries heat north from the Earth's equator, and it also carries colder air south towards the equator because it's always trying to equalize that heat. So there are overarching wind patterns that we have. Now notice this is the equator, okay? And the air is moving towards it. These are called trade winds, and you've probably talked about that in social studies. These are the winds that Christopher Columbus would use and that they would use to do their trades to create that triangle of trade. Well, where we live up here in the northern hemisphere, these are called the westerlies, and they actually move in a general southwest to northeast position. So if you think about it, with us living in Longview, Dallas constantly is getting hit with storms before we are because Dallas is to the west of us because of those overarching wind patterns. Big weather patterns tend to come in from the west. And then you go up a little bit higher, and these are called the polar easterlies. Now notice they're always exactly opposite because of how the convection is truly occurring in the atmosphere. These arrows are just showing you how it's moving on the Earth's surface. Like that's what we feel, the wind. So notice how they go head to head, and then they go tail to tail, and then head to head, tail to tail, head to head. So they're always going to be opposite. Okay, so this is what's truly happening, and this is how we're feeling it on the surface. All right, so remember the convection demo that Miss Wheelis did while I was out on maternity leave with the water and the food coloring, and you learned she'd put the cup of hot water under the tub, and you saw that as the water would heat up, it would rise, and as it cooled down, it would sink. Again, convection. So the next few slides are going to show examples of how the Earth is trying to equalize itself through wind patterns. So here you go. Here's a picture of air masses, and we talked about that Monday, the 4 different types of air masses. If it develops over land, it is called continental, and it will be dry. If it develops over the ocean, it is called maritime, and it will be moist. And then latitude-wise, if it's very far north or south near the poles, it is considered to be polar, which means it's cold. So for example, this maritime polar is going to be a very cold, wet air mass. So if this air mass right here is to move over the New England area, it would be very cold and rainy. Where if this maritime tropical air mass that's developing over here over the Caribbean, it's still over the ocean, so it's going to be very moist, but now it's a lot warmer. If it was to move up into Florida, it would be warm and again a lot of rain and very humid. Okay, so air masses are extremely large, and this is normally what can occur to our day-to-day weather. So it's like I was telling somebody, even though it's officially spring, we've been having a lot cooler temperatures than when it was still winter in early March. Obviously, we have been experiencing a cold, a polar air mass has moved over the Texas region. All right, so prevailing wind patterns. Here's another, this is a really good picture kind of showing the arrows. Here's the trade winds, the westerlies, which is what we experience, the easterlies, and then showing the convection cells that's actually occurring depth-wise in the atmosphere, which we call Hadley cells. So if you want to take a minute and pause the video and draw this picture, because you are going to need to know the way the wind patterns move based on the latitudes. Okay, so here's the equator. This is the Tropic of Cancer right here. And this one is the Tropic of Capricorn. Okay, So you're also going to have to draw this picture as well. So let's talk about why we have deserts and rainforests located in certain areas. Okay, we talked about how the equator gets the most direct sunlight. Okay, so because the equator, which is 0 latitude, is getting the most direct sunlight, the air is going to heat up faster and it's going to rise because it's going to become less dense. Well, as it starts to rise, it condenses, and there's a lot of water around the equator. It's going to create a lot of rain. Then, as it heats up and it's going to start to cool off, it's going to expand, and then as it gets cold, it's going to condense and to sink back down. And this normally happens at 30 degrees north, the Tropic of Cancer, and 30 degrees south, the Tropic of Capricorn. Okay, this is where we tend to have most of the deserts. Most of the deserts in the world happen to fall right around 30 degrees north and 30 degrees south. Now, it's not just a coincidence, it's because of the way convection works in the atmosphere. As things are rising, most of the rain is going to be dropped at the equator because it's hot and it's moist, and then it evaporates faster. So the more evaporation you have, obviously the more rain is going to be there. As it expands out, it's already lost its moisture, it gets cold and sinks, so hardly any rain occurs at the 30-degree north and south, hence deserts. And then again, it moves because we're trying to equalize that heat, so that air is cold, and so it's going to move back to the equator because these are our trade winds. These are our westerlies in the southern hemisphere. And then again, it's going to heat up and rise. So we're going to have a lot of rain in the 60-degree north and 60-degree south latitude. And it's going to expand and then sink. Okay, so take a moment, and I really want to see this picture in great detail in your notes because I will be checking it. But this explains why there are certain patterns, why the tropical rainforests tend to be around the equator, why we do have other really good forests around these latitudes. It's because of the convection of these Hadley cells that are occurring inside the atmosphere. And why the wind moves the certain way that it does. Again, just another picture, same thing. This is showing you pretty much what I just showed you, and the last one was in detail. This is, very general. We have warm, moist air, dry air, lots of deserts, warm, moist air, tropical rainforest, that kind of thing. Okay. All right, so let's go from the air into the ocean. Now, oceans hold a lot more energy than the atmosphere does, and this is called specific heat, meaning how much energy does it take to heat up 1 milliliter of water 1 degree Celsius. That's the definition of specific heat. And in 6th grade, you should have talked about how water has the highest specific heat, meaning it takes a lot more energy to heat up water than it does air or any other thing on Earth. So because of this, oceans are actually going to influence the climate and our weather more than anything else, okay? And an example of specific heat could think about it, during February, it actually got up into the high 80s, but would you go swimming? No, because the water is still going to be freezing, because even though the air can heat up and cool off extremely quickly, it's going to take water a lot longer to heat up. Another example would be like when you do go swimming in the summer and it gets dark outside and it can get a little chilly, and you kind of always sink down in the water up to your head because it's actually warmer, because the water is holding on to that heat a lot longer than the air. So that's what we mean when we say specific heat. Okay, so let's talk about, there are 2 types of ocean currents. There's surface ocean currents, and then there's deep ocean currents. So surface ocean currents are obviously going to be located on the surface, and they are mainly caused by surface winds. So if you look at this picture, notice there's a lot of red. Those are, again, warm ocean currents, and the blue are going to be cold. So warm water at the equator is always going to move towards the poles. It is trying to take that heat away from the equator and take it to an area that needs it. So warm currents are always going to flow away from the equator, And because water is less dense when it's warm, it's mainly traveling along the surface. And cold ocean currents are going to be flowing towards the equators to heat up. And because water is a lot more dense when it's cold, these currents are going to be running deep at the bottom of the ocean. So the color warm is always going to be represented by red, and cold is going to be represented by blue. So if we look at this picture, notice how the red is always moving away from the equator, no matter what hemisphere you're in, where blue is always moving towards the equator. Okay, so as the water heats up, it's going to travel up to the North Pole, where then it gets very, very cold and sinks down, becoming a cold, deep ocean current. Continues to go back to the equator along the bottom of the ocean, where it gets up here and rises as it heats up. And that is what creates our ocean currents. So if you look at this picture, I just want to talk about a couple of things. Living in Texas, many of you have always probably gone, if you've ever been to the ocean, which I know most of you have, you've been swimming in the Gulf. Well, the Gulf is extremely warm. And if you look right here, it's the Gulf Stream. They're not showing it, but the Gulf Stream actually does come in here and do a little bend around Florida and then shoot up the East Coast. It is coming from the equator. It is a warm ocean current that's traveling and taking that heat up north to Greenland and Norwegian. Now, if you've ever been to California or been in the Pacific Ocean, it is extremely cold. And the reason why is because there is this cold front or this cold current coming from Alaska and heading down towards the equator where it can heat up. So think about it. You could be in San Diego, or you could go to the Hamptons, which is in New York State, north of New York City, and it's actually warmer to swim in New York than it would be in San Diego. And it has nothing to do, even though San Diego is a lot farther south, but because of the type of ocean current that happens to be going by. So ocean water and currents they do affect the climate, and not only because they have a higher specific heat, but because there's a lot more ocean than there is land. It takes more energy to change the temperature of the water than land and air. Water warms up and cools off much, much more slowly than land and the atmosphere. So if you look at this picture, okay, you can see this cold ocean current that's coming down, all right, where the Gulf Stream is going up. So it is actually, if you look at here and look at London compared to Maine, right here, Maine is going to have warmer water than London. So a strong, very fast-moving, warm current that starts in the Gulf of Mexico moves up through the Atlantic Ocean. Because it brings warm temperatures with it, the Gulf Stream makes England's climate much warmer than it would be without it. So if England did not have that ocean current coming up, it would be even colder than it is. Right, so here's a picture kind of like the one I showed of the air, but showing the temperatures of the water. The climate near the coastline is always going to be changed by the ocean. It will not heat up as much in the summer, and it will not cool down as much in the winter as a place that's inland. Okay, so if the closer you are to the ocean, if you live on an island or you live on the beach, the change of the weather is going to be a lot slower because of that specific heat of the water. Where if you live very far inland, away from the oceans, we know that we can be in school and then step outside and it could drop 10 degrees within an hour outside. It's less likely to do that near the ocean because of that high specific heat. All right, so let's talk about land breezes and sea breezes. This is something you definitely need to draw in your notebook, okay? So let's look at this. So on a sea breeze, right? Here's land, here's the water. Notice the land is hotter than the water because it heats up faster. So that means the air above the land is going to heat up faster, so it's going to rise. It's then going to move out. Now it's over here over the water, so it's going to cool off and sink and then move back. Notice the convection cell, again, because of the different temperatures and densities. So during the day, because the land heats up faster, This is what we call sea breezes because the wind is coming off the water. And if you've ever thought about it, if you've ever been on the beach, it's always windy, correct? Well, the reason why it's always windy at the beach is because you're at that border of land and water, and the two are always going to heat up differently. That land is going to heat up and cool off much faster. So that's why it's always windy at the beach. So now let's say that the sun goes down, and notice now the water has only dropped 2 degrees where the land has dropped to 35 degrees. So now that it's nighttime, the land has cooled off a lot faster. So the water is a warmer area. So the air above the water, is going to rise and then expand out. Now it's over the land that's colder. So it's going to get cold and sink and then move back. So at night, if you're standing on the beach, the wind moves the exact opposite way and moves from the land towards the sea. So we call these land breezes. Okay, so you need to know that during the day, the wind blows off the sea, and at night, it blows off the land because of convection and because of that unequal heating between water and land. Go. Here. You're interrupting my video. Now you're going to hear yourself later. Sorry. It's okay. You should not. Okay, so land breezes and sea breezes occur because of that difference in specific heat of land and the water. And the differences can create ocean convection currents, just like we showed. All right? So when you get in class tomorrow, we'll be starting this activity.